Hi everyone, I'm Peng from Shanghai Jiao Tong University. This video will present our work Fingerprinting Deep Neural Networks Globally via Universal Adversarial Perturbations. Deep neural networks are intellectual property to their owners, as on one side it is used by tremendous IT company and has high commercial value. On the other side, its rising parameter size results in huge training costs, including computation, dataset collection, etc. In consequence, attackers may want to steal a black box victim model, which is called model extraction attack. The attacker queries the victim model with some data, then collect the returned responses and train a functionally similar piracy copy. This attack is hard to prevent, as any models with reasonable accuracy leak information, which enables extraction. So in this work, we build an ownership verification mechanism, which decides if a suspect model is victim model's piracy copy. We call models obtained by extraction as piracy models, and other models accidentally resembles the victim as homologous models. To identify piracy models, we used the fact that their decision boundaries are similar to the victim, which is a precondition for their similar performance. So we concentrate on fingerprinting models' decision boundary in a black box way. Former work view DB as separated vectors, and then use the output of the model on local adversary examples, marked as red points, to fingerprint models DB locally, which indicates if DB is to the left or right of data points in local regions nearby. However, as DB shifts during extraction, red points may not always lie on the same side, meaning that profiling DB locally can't always work, so their performances are not stable. In this work, instead of fingerprinting models DB locally, we will view DB in whole as vectors followed certain distribution and fingerprint it globally. To do this, we leverage universal adversarial perturbations, which is a vector normal to most of the DB vectors, so that it can fool the model on almost all data points. We observe projection value of three kinds of models towards the singular vector of victim models' UAPs. The gap between lines indicate UAP inconsistency. We conclude that similarities between piracy models and victim model is captured by consistency of UAP. Based on all above, we propose a verification framework consists of fingerprint generator and fingerprint verifier. The UAP-based fingerprint is designed as the concatenation of predicted soft labels of model on selected data points and their corresponding universal perturbated data points. As for fingerprint verifier, the encoder is trained in a contrastive way that projects high-dimensional fingerprint to low-dimensional hypersphere, where victim and piracy fingerprints fall on the same side, resulting in a similarity approaches 1, and homologous fingerprints fall on opposite side, resulting in a similarity approaches 0. Experiments are conducted, and we found that UAP-based fingerprints have good distinguishability, as the similarity gap between piracy models and homologous models are greater than 0.5. Using Gaussian thresholding, Defender can safely detect piracy model with 99% confidence and achieves 99% accuracy in less than 20 fingerprints. We further test that if a smart attacker wants to avoid detection through modifying piracy model, it needs to sacrifice great utility. In summary, in this work, we use UAP to globally fingerprint models DB, and then leverages contrastive learning to verify piracy model. The framework is tested to be accurate and robust. More insights can be found in our full paper. Thank you.